Okay, so this is kind of the last topic I want to talk about, especially if you're going to take the Regents, just so you're familiar with the notation. So the learning target is I can identify an arithmetic sequence versus a geometric sequence and write the formulas in sequence notation. And then the second one is I can write a recursive formula based off the first term and common difference. So first I want to talk about what subscript notation is. Subscript notation is used when you are ordering numbers or values. For example, if you have a list of terms, we could label them with subscripts. So, like if I had a list of numbers, like say 3, 6, 9, 12, 15, right? So like this would be the third term, or I could call it a sub 3, right? It's the third term in the sequence. This is the first term, so I would call it a sub 1. So subscript is really used for ordering numbers. So say I had a sequence, a long sequence I didn't know, and I wanted to talk about one of the terms. So I could say in term in general, so maybe I call this a to the n, then I could call this one a to the n sub 1. So that means I'd have to add a 1 to get the next term in the sequence, right? And then this one could be called a sub n minus 1 because I want the term before, or a sub n minus 2. Right, so that's another way that we can order them and look at them. So you're going to see a lot of subscript in this, and really the notation is probably the hardest part. So for example, if we look at arithmetic sequences, arithmetic sequences are a set of numbers generated by adding or subtracting a specific number known as the common difference. So a sub 1 is always the first term. N stands for the term number. We don't know, it's kind of general unless we know what term we're talking about. And then D stands for the common difference. So let's talk about an example. It says write the formula for the following arithmetic sequence. Use your formula to find the 10th number of the sequence. So my first term in the sequence is 4. That is a sub 1. Then N is what the general term in my number is, and D is what I'm adding or subtracting by. So from 4 to 19 is 15. So I'm adding by 15. 15 is the common difference. So I can write a sub n is equal to, when I take the first term, which is 4, and whatever term I'm talking about, I can multiply it by, or the common difference is 15. So you might see it like this. We more commonly write it like this, where I write the common difference in front. So you can write it either way. All I did was switch the common difference to the front. So if I want to find the 10th term, then I would say I want to find a sub 10. So in order to do that, I'm going to plug 10 in where I see n. So if I simplified that, I'd have 4 plus 9 times 15. 9 times 15 is 135 plus 4. So a sub 10 is 139. So my two answers, that would be the general formula for any term in the sequence. I could change n, and this is specifically for the 10th term. So you can do another practice with number 2 there. And you can try 3 and 4. So that's arithmetic. Those are like linear sequences. They're adding or subtracting by the same thing every time. We also have what's called geometric sequences, and this is when you're multiplying. So this is more of like an exponential relationship. So again, we have similar notation here. A sub 1 stands for the first term. N stands for the number of the term number. It can be any number. And R stands for the common ratio. So what am I multiplying or dividing by every time? So in this first one here, this first example, my first term is 5, so that's a sub 1. And then I've got to figure out what I got to multiply by 5 to get 7.5. So I'm going to do 7.5 divided by 5. So that means I'm multiplying by 1.5. So R is going to be 1.5. So now I'm just going to use this generic formula that they gave me and just sub in my number. So I have a sub n is equal to a sub 1, which is 5, times my ratio is 1.5 to the n minus 1. Okay, and so that's my general formula for any term in the sequence. So that's part of my answer. Now I want to find the 10th term, just like I did before. So if I want to do that, I got to plug in 10 for n. So I would just plug in 10 wherever I saw n. So when I simplify this, I have to do exponents first. So I'm going to simplify 10 minus 1, which is 9. And then I'm going to do 1.5 to the 9th power. And then I'm going to multiply that by 5. I actually get like 192.21. I'm just going to put ... to say that it goes on forever. So that would be the 10th term in my sequence. And so I could do that for any of them. So that's geometric. Geometric is just multiplying every time. So multiplying or dividing. And arithmetic is adding and subtracting. Okay, the last kind of thing I want to talk about is what we call recursive formulas. And so all we really need to do is be able to read them. So again, it's that subscript notation. So in this formula, I see a sub n, so that's the term number. I have to take whatever the previous term is, because if a sub n is that term, then the one before it is going to be a sub n minus 1. I got to multiply that by 2 and then subtract 11. So this tells me my first term, so 7 is a1. To get the next one, I'm going to multiply 7 by 2 and then subtract 11. So I'll do 2 times 7 minus 11. And that gets me 3. So the next term is 3. This is a sub 2. So then I'm going to take 3, and then I'll do 2 times 3 minus 11 to get the next term. It's negative 5. And I'll do the same thing. Take negative 5, multiply it by 2, subtract 11, and I get negative 21. So that would be a sub 4. So I kind of use the first term and the term before to get the other terms. So in this formula, you're kind of using the first term and then using the formula to get the next ones. Okay, so just try to complete that practice, and you can always check your answers in class.